All right, so if you already know what the BCOTI is, you can kind of skip this part. But for the people that want a quick overview, I'm going to do it now. So essentially, this is a clip-on thermal imager, same concept as like a PS29 or the Jerry's C or Jerry Pro series. Saffron makes some COTIs as well. Um, and the idea is that you have your analog NV unit, right, with an image intensifier inside, and then you kind of I'm going to take the sidewall off for now so you can see a little better on the inside. I'm going to put it over here. I'm going to lock it in place. See that I have it lined up properly. There we go. And now you have it attached to the front of your unit. You can do this for monos, you can do this for binos, you can do it for biocs, you can do it for quads. So, and the idea is there's a little display here on the bottom, and there's a lens and a prism, and they reflect the light from the display into the actual objective lens of your NV unit as if the image were at infinite distance. So when your unit is focused at infinity, the overlay will be in focus too, and the overlay will be whatever the camera core outputs. So there's a 256 core thermal, it's a 12 micron pitch sensor with a 9mm lens, so you get about 19 degrees FOV in the actual unit. Because of the display and the lens, it's more like 17 by 13 degrees. And if you wanted to, you could crop it to a circle, or you could crop it to a rectangle with equal sides. But for now, the stem is about 17 by 13 degrees, covering the center of your image. Exactly. So I'm going to put up some videos just now of what this looks like in practice, and then we'll jump into the 3D printing instructions. Alright, so we're on the slicer now, and I selected like a basic 0.12 millimeter layer height profile, and we're going to start importing some of the files. So here in the CAD folder, go BCOTI CAD files. You'll find the camera cage, the body shell, and then the mounting clips. You'll find the different clips for the different devices. Okay, so when we go here, it says 3 to 4 wall loops, 22 to 35% infill, and we're going to want tree supports for this. So we're going to import this one. Looks like that's the one I need. But you'll probably need the PVS14 or Anvis or whatever. Then we're going to need the camera cage and the body shell. No, that's fine. Okay, so auto rotate, arrange them. Okay, so let's do 3 wall loops. Let's do 25% gyroid infill, and let's enable supports to be tree. And we can actually we want to also do small overhangs because there's some nooks in here that you definitely want to be clean. Okay, so this is gonna get close, so let's rotate it like this, I guess. And by default, it's not actually going to add supports to this part. I mean, at least with the filament that I have selected, it depends on the overhang that you have configured. But I definitely do want this to be supported, so I'm going to fill that. And then, but now that I've disabled that it skips these small overhangs, it's also going to try and do these. That's kind of unnecessary, so I'm just going to remove them. It's just unnecessary tree support that it's going to try and add to them. Okay, now we're going to slice it. Okay, let's see here. Okay, that looks slightly scuffed, so I'm going to have to move this part slightly more over here. And then the rest looks okay. Yeah. Alright, so we can send this off, and this is going to be our first batch. The material that you use for these, I'm printing these out of like a PLA, or you can do PETG, or you can have them SLS or MJF print or whatever. For that, it doesn't matter much. They don't have to be as matte as you can, so, but now that I mentioned it, let's go to the next plate. And to the next plate, we're going to add all the parts that have to be like a very matte material. So let's add the stem cover, and the display spacer. It's not multiple parts, and let's do arrange. Okay, so this can lay flat, and this should lay on this little edge here, so that this part kind of forms a 90-degree angle here at the bottom. Okay. And then for this, we're actually gonna change the supports over back to normal, and we're gonna do snug, and we want it to be only on build plate, and it can skip the smaller stuff. Like, or depending on your printer, this overhang might not print fine. In that case, you can remove the build plate only, but it'll also try and do this part down here. And I guess with a small screwdriver, you probably can push it out, but you're gonna want to try and keep this as clean as possible, because the mirror and the lens slot into there. So I'd say if you really do have issues with this, then maybe just go into in painting, right, and color that part in. Let's see if it, yeah. Now it would add, now it would kind of ignore the rule about build plate only for this very small part. Okay. So, and these parts, they should be a very matte material, right? Because if you have light coming from the display, it might also hit the walls. And if your walls are like a, I don't know, very bright material, or they're very glossy or whatever, the light will bounce around a bunch, will end up in the prism and go to the lens. And it's not going to give you, or it's probably not going to give you a blurry image, but it'll definitely bloom out your the actual area more than it has to. So I'd recommend if you're getting these printed in MJF, SLS, or whatever, try and get as matte of a coating or whatever as possible. And if you're printing these FDM, maybe get like a matte PLA or matte PETG or whatever. Normal PETG probably also works fine, but like sometimes it turns a little bit too glossy. It's not going to kill like the usability. It's just you want to try and get it as good as possible, right? So let's see. I think that is all I have to do in terms of the settings. Okay, and that looks good. And snug support is just going to make it much easier printing this whole thing on its side. And at the end, you can just take some pliers and you can rip off this whole thing. It's quite easy. All right, and then we're going to add one more plate. And whoops, that was one too many. To the last one, we're going to add the bikini cover. This one's kind of optional, but I would recommend it. The idea is you print this out of a very soft, like TPU 95A Overture is what I used, and you print this orientation, and it just goes over the germanium lens of the thermal sensor, because it does have a shutter to protect itself, but that shutter is actually open when you don't connect it to power, which means that if you disconnect power from the unit and you have it laying around and the sun has a chance to like shine onto the germanium lens, it'll focus onto the sensor and it'll actually burn it, and it's pretty bad. So by default in the firmware, the burn protection is on, so during the day if you do look up, it should try and close it before it does any damage, but of course it's not recommended either way. And this just kind of guarantees that if you put it somewhere, that it's not a risk. Okay, so for this one we're gonna, right, I sliced the other ones to TPU already, but like the other ones aren't TPU, this one's TPU. Alright, and so while these print, we can do the electronics. The tools that you're going to need for this are a soldering iron, some solder. You're going to need a way to put the heated inserts in. There are these special tips for some soldering irons that you can then screw on the correct size for the inserts. But for the M2 ones, you can also just use like a normal, somewhat thin tip, and that'll work fine as well. Then you're going to need a screwdriver, a hex key for the M2 screws, some pliers, some clippers, a wire stripper, and some tweezers. Just make the assembly slightly easier. And I'm just going to say this beforehand, if you do end up building one of these and you're happy with the result, and you want to support further development, there's a, I do have a Buy Me a Coffee page. I'll put the link right here. It's also on the GitHub repository. Yeah. Alright, so let's gather all the parts. Look at the repo while I'm doing this. Okay, so this is the camera. Right, this is the Mini 2. And we have the screen and driver. and the cable that comes with it. Then we have the ESP mini board. Then there's the USB-C breakout connector that's going to be connected with the ESP32. Then we have the actual USB-C port that's going to be on the back of the unit. Then we have the small reset toggle switch for the brightness of the display. Then we have the potentiometer for the on-off of the unit when you hear the little click sound. That's how it turns on, and then you turn the knob for more or less camera brightness output. And then we have, okay, we're gonna need some 26 gauge wire. I have it in a few different colors. We're gonna use red for our 5-volt net, black for the ground net, and use yellow for the, as much as I can, I'm gonna use yellow for the analog video signal going from the camera to the display. And then we'll use blue and white for the some of the data lines. Exactly. Then we have the momentary button. That's going to be the multi button on the back of the unit, or on the bottom. Then you're going to need some. In the repo, I actually have this as a complete cable because the camera does come with a JST cable, but for some reason only the power, ground, and video pins are actually used. Like there's no UART pins. So in the repo, there's actually just a link to a 5-pin cable. I just happen to have like a set of cables that already have these connectors crimped on, and then I put them into the plugs, but that part's not that different. And then you're going to need some heat shrink to insulate some of the cable connections, making sure it doesn't short out. Okay, so about 80 millimeters. We're going to need some pliers. So about this long. There we go. Now I'm just going to separate these slightly. Okay. Now we're going to get a wire stripper, and we're going to strip some small parts of the end of that cable. This much, so very small portion. Okay. Okay, so now we're just going to grab our soldering iron. I'm just going to put a bit of solder onto the ends of those cables. So we're going to need a pretty long piece of wire for our 5-volt net. Another 80 millimeters. I'm just going to measure this out again roughly. I mean, it doesn't have to be exact. It's just makes it a little bit easier to work with. And then we're going to need 3 pieces of red wire about 30 millimeters long. It's slightly more than 30, but it's fine. Okay. And now we're going to use the wire stripping tool again. Now we're going to strip a lot more than we just did on the USB-C port. Maybe about this much. So like quite a bit. Enough that you can twist them together in a moment. And then you just twist all of them together. Just so they start like bunching up. Like this. Just so you have a nice like compact bundle. And we're gonna put solder on them. Once the solder iron is hot enough. There we go, and then you're just gonna put enough solder on there that the whole thing kind of becomes one. Okay. And once you're done with that, you can clip a majority. You can just clip it off again, right? Like, because you're for soldering it onto another wire, you're not going to need this much. So I'd say about, you can reduce it to about this much. If you take too much off, it'll come apart. Like the bundle will come apart the moment you solder it onto another wire. But I think this should work as an amount, right? So now I'm going to strip a normal portion of both ends of this cable. Now we're going to do a similar thing for our ground net, except that instead of a bundle of 3, we're going to build a bundle of 5. Alright, then same step as before. Take the wire stripper. And then take off a good portion of the insulation again. So like, again, something like this amount. Enough that you can twist them together easily. There we go, that looks good. The lens, there we go, like maybe about this much. There we go. Alright, so these pins here on the bottom, these are the on-off switch. So, and the moment you turn the knob and you hear the click sound, then those pins are connected together. So what we're going to do is we're going to take the red wire we cut, and we're going to solder it onto one of those pins. Which of the two doesn't matter, it's just that you're going to solder this red wire onto one, and then later, after you've inserted this into the actual body of the housing, then you can solder on the other part. There we go, that looks pretty good. There we go. We solder the bundle. We solder that onto, or solder a 5-volt net bundle. We solder that onto this. And then for this, I'm going to use slightly bigger heat shrink. There we go. No, I'm just gonna. There we go. Put that aside for now. Now we're gonna have to strip the ends from our ground bundle. And we're gonna have to do that with the 5-volt bundle in a moment as well. One of these I actually did slightly too long. Here on this one. I'm just going to cut a little bit off again. Okay. Now the idea is that there's a bunch of components that need 5 volts and few that only need ground. And now we're going to solder those. For this port and for the pins, or like the pads on the ESP32, I like to use a little bit of flux, or well, a little bit, I shitloads, but that just makes it much easier putting solder on them initially. Okay, now we're gonna have to do the 5-volt bundle. I could have probably done that in a better order. And now we're going to put the 5-volt connection on the USB-C port as well. So that's what it's supposed to look like. On the left, where it says VCC, that's where the 5-volt wire is going to go, on the ground is on the other side. It's really very hard to see on the camera, huh? VCC on the other side, ground. Now the display driver cable. A lot of these are actually not connected at all. Alright. So I'm sure this is also on the website or whatever, but just so in case that you bought them somewhere else. Right, like this red wire here all the way on the right when you hold it like this. This is your analog video signal, your plus. And then there's a bunch of not connected lines. We're going to cut those off. Then there's your analog video minus. In this case, we'll leave it unconnected because the camera doesn't actually have a port for this. You could hook it up to ground, but might interfere. Leaving it unconnected is a safe way to go. And then we have our brightness plus and down controls, and then we have our voltage and ground. So we're going to make a connection to VCC and ground to that same bundle that we just did. And I'm going to cut the other wires off. Alright, so these 4 that are unconnected, black to the blue one, we're just going to cut those off. They just get in the way. Okay, and the white one, I don't know, I'm going to cut, I'm not going to fully cut it off, but I'm going to just leave it like this for now, in case I do ever want to connect it up to ground. I don't know. And then our actual power lines are this yellow and this brown one. I'm gonna cut them slightly shorter. You probably can stuff enough cables in there. There's a little bit of room left at the end, but just makes it easier. Okay, now I'm gonna use some heat shrink to put over that, because we're going to be stuffing these cables inside, so I don't want the risk of wires like randomly just touching each other. And now the last cable that we're going to do that also requires 5-volt power is that JST plug that goes to the camera. Just so that there's decent length for the actually touching the camera, but then also that it's not too much and it gets in the way the moment we try and stuff it somewhere. Some heat shrink. That's going to go over the red wire for our 5 volts. The actual pinout of the camera is on the back. There is a V for voltage, or V for VCC, G for ground, C It's where your video comes out. T is for transmit and R is for receive. So T on this one has to be RX on the ESP32, and R on this one has to be TX on the ESP32. But if you just look at the GPIO pin and layout from the diagram, that'll be easy to understand as well. That way, red is our VCC, G is our ground net, C is yellow for our video, and then blue is our TX, and white is our RX line. So now our display, the camera, and the ESP32, they all can get power. There we go. Okay, and now we can also already solder our camera connection, so we can connect the red wire from the connector that goes to the display to the center pin from the camera. That way the video just goes straight from the camera to the display. Okay, and now we have 2 ground leads on our ground net bundle left over, and those are going to go onto the toggle switch, onto the center pin, and the push button on one of the 2 pins. There we go. Now we're going to do that for the button too. There we go. Okay, and now you can take the 2 cables here, the ones next to the 5-volt and ground from the display, right? That is brightness minus and brightness plus, so that would be the gray and orange wire. And in which orientation you solder them on doesn't actually matter. It's just that if you want like let me pull up my unit. If you want brightness down to be pushing inwards and brightness up to be pushing outwards, then you'll have to position the switch that way. You'll have to remember that when we put the housing together. Okay, let's check how good these. Yeah, they look alright. And now pushing the button side, right, like to either side shorts ground to that pin, and that's what the display driver expects as a signal to adjust the brightness up and down. Okay, I'm going to use slightly longer. I'm going to use green wire for that, for connecting the push button to the ESP32. Now we're just going to strip a small bit from the end, just enough so we can solder onto the pad of the ESP32, like the GPIO pins, and I can put the other end onto the momentary push button. There we go. Now we're going to get the ESP board. We're going to rip it off on the top. Right, so on the bottom here, there's the numbers for the GPIO pins, and those are accurate. So if I write 21 in the instructions, that also means the pin that's labeled as 21. Put flex on these. Okay, now when we attach the cable, the important part is it has to be on the underside, and it has to be facing inwards. That way the cable is not going this way, but it goes in. up to the connector. Now we're going to connect the RX and TX lines from the connector here. We're going to connect those to the ESP32. So I'm going to put a bit of solder onto pin 1 and 2. That's where we're going to put the UART wires. This is the most outer cable. Is going to go to GPIO1. And then the other one, the TX line, is going to go to GPIO2. So this is what it looks like in the end. So you have GPIO. Let's see, 1 and 2, and they're connected to the UART lines from the camera. And then the button that I just did, right, goes to 21, which is on the bottom right here. Okay, now we're going to need to do the potentiometer. This one actually has 2 sets of wipers. Which one you use doesn't matter as long as you're consistent, right? So you can't mix the 2 rows. If you're going to be using one of the top row pins, then you can't use one of the bottom. They have to all be top or all be bottom. That's what the instructions say. There we go. So we have 3 wires. We're going to need one for 3.3 volts, one for ground, and then one as our sense wire, where the actual voltage from the potentiometer goes onto. So I'm just going to strip the tiny piece of each of the cables from both ends. Okay, so on the very left side, so on this very left pin, that's where your ground is going to have to go. Middle is going to be your sense wire that goes to the GPIO pin, and then all the way on the right is your 3.3 volts. That way, the moment you turn it on with the click, it's going to read as 0 volts, and as you turn it up more, it's going to read as 3.3 volts, which is the expected behavior from the firmware. Sense wire. And we're going to put solder on the G, 3.3, and 4 labeled pin pads. There we go. And then our yellow wire goes to 3.3 volts. So, like this. Ground goes with the black cable. And then green is our sense wire, which goes to GPIO4. And at this part, the electronics are almost done. The only thing that has to be done now is that the from the USB-C port, the 5 volt has to go onto the potentiometer, and the ground line has to go onto the ground line directly. And then your white and blue wires, so those are your data plus and data minus for USB. They go onto the breakout board here in the center 2 is data minus on the left, data plus on the right. That's where your white is going to go onto the left one, and then blue is going to go onto the right one. but you can only do that once the port is inserted into your body. So that's what we're going to do now. So this is the main shell, and this is going to be your camera cage. So for now I'm going to take the main shell, I'm going to take the tree supports off. Probably makes sense in this orientation. So I'm just going to put all of the wires through. And this is also why they have to be this long, and that way you can still access them once you push it through. And now I'm actually put a tiny drop of super glue onto the edges here. There we go. And then this is what it looks like on the side. Might want to clean up the super glue a little bit, but okay. So now we're gonna make the connections through the actual housing. There we go. And now we're gonna connect the 5-volt wire is going to go to the other pin for the on-off switch of the potentiometer. There we go. There we go. And then the last two wire or solder connections we're going to have to make is to the to the data lines of the USB-C port. So data minus is the white wire. And data plus, or D plus, is the blue wire. And now you're going to want to program the ESP32. If you flash from an ESP tool or other like console, then it'll work just fine. If you do it through the port on the back, but if you flash via the web browser, you're gonna have to do it while you have access to these two buttons. Yeah, these two buttons, you're gonna have to push the boot button, this left one that says boot. You're gonna have to push it when you connect it and flash via the web browser. Before we insert, we're gonna hold down the boot button. And then we're going to insert the USB. There we go. I'm going to say connect, and we're going to choose the COM port. Here we go. And now what we're going to do is we're going to look at the GitHub repository. Under compiled binaries, there's a guide here. So 0x hex 0 is going to be our bootloader, hex 10,000. 1, 2, 3. Is going to be our actual partition for the app, and then hex 9000 is going to be our 8,000? Yes, 8,000 is going to be our partition table. So I'm just going to go to where I have mine, count files, ESP32, compile binaries, partition table, BCOTI, and then bootloader. And then we're going to click, let's do erase. It's going to take a moment to erase. At the start, you probably don't have to erase it. It'll override enough. What you might have to do is if I change something about the presets, like for example the amount or the certain style, essentially, then you might have to erase it before, and it'll delete all of your saved presets, because it messes with the structure of how I store it in the flash. It's just not going to read it out correctly. Okay, and then after erase it, you just click flash, and it says flashing. Alright, and then it says run the new firmware, reset your device. So we're going to press the right button. Now disconnected, and now it's good. Let's check if it turns on before I put the wires back on. or the heat shrink. Yes. So the display turns on. So turns out it does have reverse polarity protection. It's good. Okay. We're gonna insert it in like this so that these are on the bottom here. I put a washer, and then I'm gonna put a hex nut. And then I'm just gonna you can kind of just twist against the knob, making sure that it's actually straight. Because if it's straight, then the other one will fit through. So that this switch right here, and then the washer and the hex nut. And this one you kind of just crank. It's gonna push against the potentiometer, but it should stay straight. Yeah, left, right, there we go. Okay, now with the USB-C port inserted into the dev board, right? So here's the USB-C male plug. It's inserted into the ESP32 so that this writing is on top. You're going to want to insert it in like this. There's like two slots in there. Kind of hard to see with the camera. Right, now you can kind of see it. There's two slots in there. The center one, the one that's on the arrow right now, I'll mark it in post. That's where the ESP goes. So this connector faces down, and then the writing that says Super Mini is facing up. It's facing that way. Right. I'm going to take the push button, the momentary push button. I'm going to insert it into this hole on the bottom here. Small little washer plate and hex nut. There we go. Now the button is nice. And you're just going to want to make sure that the slot in the top here, let me change the focus, the slot above the ESP32, that there is not many wires in there. It should be mostly empty. The few wires that go down to like the potentiometer is fine. But there is supposed to be some space there, because we're going to push in the driver board in there in a moment. So I'm going to open the clip for the flat pack cable, and then we're going to insert the plug like this. And we're going to bend it over, and we're going to just kind of fold these down so that they are in this orientation. And then the display is actually, it's going to insert through here. There's a little slot in the top that the cable goes through. And then just make sure, like, after printing, this top edge might not be fully clean, so it might interfere with the display. Just make sure that it's as smooth as you can get it, and then the display should fit quite well. Okay, now we're going to take the display, and I'm going to mount the flat pack cable again. Okay. And now the idea is that I push it in like this, so that this side faces towards the bottom here. It is a bit tricky to get it into the slot properly, but once you do get it in, you can just keep pushing and the cables will go away. There we go, I got it. So now you just, once it's in there slightly, just keep pushing, and the whole bundle of cables, it'll all go back. Then just make sure the ESP32 and the driver board are as far back as I can, and then you can start shoving in all the cables into the actual body. This is the display cage, right? I'm gonna just focus the camera differently again. And I like to use a very small flathead screwdriver for this, where I kind of just go around, removing the supports for the and for now we're going to need 6 screws. And then, so with the big notch at the top, we're going to put the connector facing down. Then what we're going to do is, and now the important part is for this step is that you go through them evenly. So I'm just going to start at the top left. I'm going to put 1 screw in. I'm not going to tighten it all the way, just so it catches the thread on the camera. There we go. And you'll notice that now I can't pull the core out, right, because of the 1 screw slipped in. Now I'm going to go on the opposite side, so on the bottom of the other side. I'm going to try and get the screw to catch there as well. Right, like this is the, at the start you want to evenly tighten it, and then later for alignment, if you have to do alignment via screws, then you can do it later on. And for now, I'm gonna leave the O-ring groove. I'm gonna leave that empty. I'm gonna put one in once we know everything works. You're still gonna need the JST plug. So what we're gonna do is we insert this, and now we're gonna do another test, making sure that all the wires are still good. You can see booting. Okay, and then on the display, you can see that. Now it's an outline mode, right? Like my hand is going over the top, so it works. And then you can check that the functionality works by you can turn up and down the knob, and you'll see that the brightness adjusts. And then you can also use the dabber switch to reduce or increase the brightness, right? It's kind of like tucked in here, so there's a bunch of space. And then you can kind of just push the whole camera cage. You can push it in. It'll come back out slightly, but as long as you, with a little bit of pressure, you can push it in, then it's all good. And then we can also make sure that we didn't like just break any cable connections by just turning on the unit again, right, while I'm holding it like this. You can see that it still works. Just doing the change over to outline mode. And crank up the brightness. Right, you can see my hand go up top. So the unit still works. Okay, so what we can now do is we know it fits. We can grab one of the O-rings. This is kind of optional. It's not going to waterproof the unit. It's a start. It might interfere with actual alignment, so if you're having issues, try removing the O-ring. There we go. And just make sure it sits nicely in the groove. And then you can connect the camera again. We're just going to do another test fitment and make sure that with the O-ring it also still works. Yeah. It's going to take a bit more pressure pushing it in now, but you know that you're pushing against the O-ring and not the electronic inside. You know, the O-ring is going to have to be compressed for it to do anything, and it being harder to push in is a good sign. And then we can make sure that we didn't just break any cables again by just turning on the unit again. Right, so the screen turns on, camera turns on, and you can see that it works. It's going to switch over to outline mode. It does that at the start every time. All right. So this is how I have it prepped. Or actually, let's put in the display spacer real quick. So what we're going to do now is we're going to remove the protective film, and we're going to take the display spacer. We're just going to push it in from the top. There we go. So let's just focus. So it should sit very flush, the display spacer. You shouldn't be able to tell from the sides that it's in there. There we go. You can clean this up more, but for now I'm going to leave it like that. We can put the heated inserts in. So I actually have some special soldering iron tips for exactly this, but you can the M2 ones you can put in with a normal one as well. We're going to need 11 heated inserts for now, or for this moment. Okay, so the top ones are in. Now I'm going to take the camera cage, I'm going to take that out. There we go, and now I'm going to put the ones into these rings. Okay, so now they're in. So now what we're going to do is and wait for these to cool off for a moment, because you definitely don't want to screw into them while they are still hot enough to mess with the material, because otherwise it's going to pull them like back out and whatever. Alright, so these are the optical components. This is the small prism, as you can see. And the very small double convex lens. So what we're going to do first is we're going to make sure these are free of smudges. You could do it with, like, you can put on rubber gloves or whatever, it's not that important. It's going to be way too out of focus. Okay, so this is a double convex lens with equal radii, so the orientation doesn't matter. You kind of just line it up with the slot, and then you just push it in all the way. And it's going to sit quite flush. Alright, and same with the prism. Make sure the two sides, not the hypotenuse, but the other two sides are good. Then you're just gonna insert it. Right, so this is what it looks like at the end. Lens is in front here. And then you slot in this end. Ta-da. Okay. And now what you're gonna want to do is you have this side cover here, and you're gonna want to glue this on. So what I'm gonna do is I'm gonna grab some super glue. You can be very sparing with this. Like, you just have to get it to hold slightly. That may have already actually been too much. Let's try and get a little bit off again. Alright, so I just put 2 little drops on the left and right. There's like 2 small holes, and then you just grab the cover, which has 2 little prongs, and you just line them up with those 2 holes, and then you kind of push it in place, and it'll cure quite quickly. And then what you can do is maybe with like a small Q-tip or maybe a small wooden piece, you can apply a little bit more super glue along this edge right here, but you don't have to. Depends how tight you want it, but having it on the bottom will be enough for it to. I like to keep mine open on the side here, because I'm sure I'm going to open this up again at some point, but if you really want to seal it, then go ahead. This is all cooled off, so I can grab the camera cage, connect the camera. Now you're just going to take 11 M2x4 screws by hand, and then we're going to fix it in place. And again, try and tighten these evenly, so don't fully crank on one. Just kind of make sure it catches the thread. We're going to make sure that there's no small like specks of dirt on the display, which looks good at the moment. And I'm not sure, I think this is an artifact just from printing with matte PLA, but sometimes you get these little tiny strings in the optical path here, and because the aperture is so small, they will actually somewhat be enough in focus. So what I like to do is I like to take a lighter, kind of wave it below, and they're thin enough that they will just immediately melt and go away in the moment you get the lighter close. So that should clean that up. Now what we do is, now we're going to mount the periscope. Alright, don't over tighten these, just make sure they're somewhat tight. There we go. And this is what it looks like now. And now you're just going to put the mounting clip on. Now the holes here somewhat line up. They don't have to match up perfectly. You can cut through the material a little bit. And now we just put 2 M2 screws in place to lock it. And then the mounting clip that you use will depend on the device. So for me, my locking ring is has a slightly bigger outer diameter. So I printed mine that has one slightly bigger. And now we just lock in place. Okay, and now I'll go take some images of how it looks. Alright, so just as a closing out statement, if you do end up buying the parts for these, and you assemble it, and you're happy with how the final result ended up, maybe consider dropping a small donation to my Buy Me a Coffee page. I do have some future developments coming up as a sort of upgrade kit for this to replace the analog video driver and the analog video breakout board of the camera with an FPGA, and they'll cut down on the size a lot, and would also allow for adding like HUD elements like compass, maps, and things like that. So a little bit of financial support would go a long way. Thanks for watching.